Welcome Year 11 Advanced Maths to what is the second last exercise in the course. Today we're going to be looking at variance and standard deviation. Now, we learned standard deviation in Year 10, and standard deviation is a value that tells us how far we are away from the average. You may remember we talked last year about if you have a small standard deviation, all your scores are really close together, close, and they clumped closely around the average. If you have a large standard deviation, the scores are more spread out around the average. Well, the variance is actually equal to the standard deviation squared, or the standard deviation is the square root of variance. So we'll talk a bit more about that in a little while. But what we need to do is find a formula that generates the variance. Now, before we do that, I just want to point something out that you may or may not have already forgotten. If we were talking about, we did this in a previous exercise, the expected value of x, that could be found by getting the sum of the weighted x values multiplied by their probabilities. And that also is known as the average, mu. So that's something that we've covered in the past, and we're going to actually need to use or utilize those concepts, because I want you to have a look at this here now. Variance is given by this formula here. It's the expected value of something happening, and it's your x minus the average squared. Now remember, if you're looking for expected value of x, it's a total of all the little x values multiplied by their probabilities. So if you want the expected value of x minus mu squared, it's going to be found by summing all of the x minus mu squareds and multiplying them by the probability. If you use this formula here, it's going to give the same answer, but it's a different way to get there. The variance is equal to the expected value of capital X squared minus mu squared. Well, if you want the expected value of something, come back over here. Imagine putting a squared to get the expected value of x squared. You'd have to put a squared there, and that matches up with this formula here, and there's minus mu squared. Effectively, you just have to memorize these formulas. The expected value of x is equal to this. That's on your formula sheet. That's on your formula sheet. That's on your formula sheet. So we need to be able to use them. Now, standard deviation, as I said before, is the square root of the variance, or the variance is the standard deviation squared. Right, let's do an example. A die is thrown producing a uniform distribution. Find the mean and the variance of the distribution using the formula variance equals x minus mu in brackets squared. Well, the probability of rolling your dice. Well, we've got 1 on 6, 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 1 on 6. Got one chance on 6 of rolling all of those. So our total, or our sum, is going to equal 6 on 6, which is 1. Now I want to take x and multiply it by p of x. X multiplied by p of x. 1 times 1 on 6 gives me 1 on 6. For the next column, it's 2 times 1 on 6, which gives 2 on 6. Next one's 3 times 1 on 6, 4 times 1 on 6, 5 times 1 on 6, 6 times 1 on 6, and add all of those up, and they'll add up to 21 over 6, which is 3.5. Now, 3.5 is also mu, because remember that the expected value of x is equal to the sum of x times p of x, and that's equal to mu. And the sum of, let's go back to the pointer, the sum of x multiplied by p of x is the sum of this row here. The sum of this row here is 21 on 6, or 3.5, so that is mu. Now, the next row here, we want to take an x value, so in the first case it's 1, minus mu, which is always 3.5. So it's 1, take 3.5. Once we get the answer, we then square it. And if you do that, you'll get 25 over 4. The next one will be 2. Take away 3.5, figure out what that answer is, square it, and you'll get 9 on 4. 3 take 3.5 in brackets squared. 4 take 3.5. 5 take 3.5, and then you've got to square it, of course, every time. 6 take 3.5 and then square it. We don't need to add those up. That doesn't help us, so there's no point worrying about that. But I'm going to multiply this row, everything in this row, by p of x, because that will then give me the expected value of this row, and that's what I'm chasing, the expected value of x minus mu of x. Capital X is the general case. Little x is when you're talking about each individual specific score. So let's look at this now. X minus mu squared multiplied by p of x. So 25 over 4 times 1 over 6 is 25 over 24. The next one, 9 over 4 times 1 over 6, 9 over 24. 1 over 24, 1 over 24. 9 over 24 and 25 over 24. That's what happens when you multiply them all out. Now if I add that row up, it adds up to 70 out of 24, and that becomes, as an mixed fraction will go, 2 and 11 twelfths. Now the question says, find the variance of that. Well, we know that the variance of x equals the expected value of x minus mu squared, which equals the sum of the x minus mu squared times p of x row, which is 2 and 11 twelfths. So that is your variance there. Let's go to the next one. A die is thrown producing a uniform distribution. That means it has an equal chance of everything happening. Let's go through that again. You're going to get 1 chance in 6 of getting each of the numbers. So that's why it's uniform, because they're all the same. That adds up to 6 out of 6, or 1. So now we look at the next row, which is my x times p of x row. Let's have a look at what we get when we do that. We get 1 times 1 on 6, 2 times 1 on 6, 3 times 1 on 6, 4 times 1 on 6, 5 times 1 on 6, 6 times 1 on 6, which adds up to 21 over 6, or 3.5. And that is mu, because that comes from this part here. And remember, one of the formulas, mu is equal to the sum of x times p of x, and that is on your formula sheet. Now, next thing we need to do, remember mu is the average as well. The next thing we need to do is the x squared times p of x. So I've got to take the x value and square it, and then multiply it by p of x. Okay, so it's now 1 squared times 1 over 6. The next one will be 2 squared times 1 over 6. The next one will be 3 squared times 1 over 6. 4 squared times 1 over 6. 5 squared times 1 over 6. And 6 squared times 1 over 6. They will all add up to 91 over 6, which is what our Well, let's actually look at this. What actually is it? That there is the row, and we know that if you sum the x squared p of x row, that will be equal to the expected value of x squared. Now, the question actually says, find the mean and variance of the distribution using this formula. Well, we know the mean, we found that. The variance of our x value is equal to the expected value of x squared minus mu squared, which equals, what is the variance of, sorry, not the variance of x, what is the expected value of x squared? Oh, it's the x squared p of x row added up, which is 91 over 6. Then I need to minus from that mu squared, 3.5 squared, and I need to put that into the calculator, and I'll end up with, as a mixed fraction, 2 and 11 over 12, which is the exact same answer that we got in part 1, but we've used a different formula to generate that answer. Let's go on to question number 3. Now this links back to question that we did in the previous exercise, the friends that went out to the restaurant. So let's go through the process. When we do that, 5 friends had $0, 5 out of the 20 people had $0, 2 out of the 20 people had $50, 3 out of 20 people had $60, 4 out of 20 people have $90, 2 out of 20 have $150, 3 out of 20 have $270, and 1 person has $460, and that add up to 20 out of 20, which is 1. It represents all of the probabilities. X times p of x, so 0 times anything is 0. 50 times 2 on 20 gives 5. 60 times 3 on 20 gives 9. 90 times 4 on 20 gives 18. 150 times 2 on 20 gives 15. 370 times 3 on 20 gives 55.5. And 460 times 1 on 20 gives 23. If we add all of those numbers in this row, we get a total of 125.5. Now what does that number there mean? Well, because that number comes from this row here, and if you sum that row, that's what mu is equal to. So add the row up, add this row up, that's mu, that's your average. Now, to get our next position here, I could have had an x squared column, but it's the x value has to be squared, and then you times it by p of x. So the x value is 0. 0 squared times 5 on 20 gives 0. The next one will be 50 squared times 2 on 20. 50 squared times 2 on 20 gives 250. 60 squared times 3 on 20, 540. 90 squared times 4 on 20, 1620. 150 squared times 2 on 20, 2250. 370 squared times 3 on 20, 20,535. And 460 squared times 1 on 20, 10,580. If we add this row up, it adds up to 35,775. What does that actually mean? Well, if I was to add up x squared times p of x, that's the expected value of capital X squared. Which means, let's find, the question says, comment on the distribution, probability distribution, and complete the probability distribution table and find the standard deviation of the distribution. Well, before we find the standard deviation, let's find the variance. The variance can be found by using the formula expected value of x squared minus the average squared. Now the expected value of x squared is 35,775 minus the average squared, 125.5 squared. And if you do that, you end up with 20,024.75. So that's your variance. But the question didn't ask for variance, the question actually asked for standard deviation. Well, the standard deviation is equal to the square root of the variance, which is equal to the square root of 20,024.75, which equals approximately, to 2 decimal places, $141.51. $141.51. So that's your standard deviation. What that actually means is, for this table, this data, when you look at the average is 125.5. The spread around $125.50 is a spread of $141.51 for each standard deviation. So, it's now time for you to go to exercise 13C, fill in some examples, fill in some questions. They've got tables there, and see how you go trying to find variance and standard deviation. Enjoy, and we will continue this next class. It doesn't have to be completed for homework. We've got this class and next class. Bye for now.